Welcome to the Future of Technology seminar series hosted by Harrisburg University of Science and Technology. I am Preeta Ram, the Associate Provost for Internationalization and Chief Academic Expansion Officer. We are gathered here today across 2 continents, 7 universities, and a couple of hundred students and faculty. Now, if you haven't registered, please do so. You can register at global.harrisburgu.edu. And if you register, then you will be able to receive updates on seminars and changes and things like that. Now, every day, hundreds of students receive the very latest industry-aligned, state-of-the-art education in science and technology at Harrisburg. And yet, we realize that 85% of the jobs that will exist in 2030 haven't even been invented yet. And for students like you, that makes it pretty challenging if you're planning your educational and professional journey. And so, even though we can't predict the future, we thought it would be helpful to gather up some of the smartest people we know and to ask them to give us their opinion on what the near future of technology would look like. And so this evening, to start things off with A, of course, with A for Amazon, we have Raefer Gabriel. Raefer leads research in engineering and product for Amazon Alexa. He started with a bachelor's degree in Harvard, followed by an MBA from Columbia, and stints at several startups as co-founder or CTO. And it's made it easy for him to pick up enough AI to lead the conversational AI team at Alexa. Right now, he's working on making Alexa more conversational, and he runs the Alexa Prize, a $3.5 million university challenge to advance human-computer interaction. Raefer, welcome, and we'd love for you to take some time to tell us about your educational journey, your insights, and all that before you dive into the technologies of conversational AI and your vision for what the future of technology looks like. Over to you, Raefer.
Thank you so much, Preeta. This is really a great honor to be able to share for everyone here. I'm going to start out by walking through my own background a little bit. And if you bear with me for 1 second while I get my slides up here. Fantastic. So just by way of introduction, my name is Raefer Gabriel. You can hopefully see it there on the screen now. I lead the Alexa Prize team and the Conversational AI engineering group, and I'm a manager at Amazon Alexa AI. And I just wanted to kind of frame things a little bit for everyone here tonight. What I'm going to talk about is how to think about tackling big challenges in your career and your life, and hopefully present some examples from my own background and show you how I've thought about some of the big challenges that I wanted to tackle, and how I've helped use that as a guidepost to steer my own career decisions. Just give you this sort of me in a nutshell picture. This is my voyage into the tech industry. I actually started out studying physics at Harvard College. I graduated way back in 2000. I know it's ancient history these days. It was a different economic boom cycle back then. When I was finishing college, I was thinking about the hot area at that point in time, or one of the hot areas at that point in time, which was entrepreneurship. And I was looking at the financial technology space. We called it financial technology. We didn't call it fintech back then. It's got a cooler name nowadays. And I went in that direction right out of college, started my first company back in 1999 before I even graduated. We sold that company a couple of years later, and I ended up going back to business school. And I went to business school at Columbia, which was a great experience as well. Again, I was kind of studying in a somewhat different direction maybe than I ended up going ultimately. I majored in finance in business school. And as I was finishing up business school, I was looking to apply some of the things that I learned there in some of the statistical methods from finance to the consumer product space. And I had always been very interested in this world of artificial intelligence. It was something that was, it struck me as a point where there was a lot of opportunity for impact, and an underutilized set of capabilities in the industry. So I started looking at how can I take my entrepreneurial background and create value for one or more industries in the tech space, based on the things that I do know how to do well, which is to say, really learn and communicate and dive deep into research areas. And that's really, I think, a lot of what I was bringing to the table in this space. My first step in that direction was a company called Reputation.com. And we were looking at the time at this big problem of how do we find information out there about a specific person and help them manage the profile and persona that they project on the internet. This became a space called online reputation management. I was one of the co-founders of this company, and this was one of the first kind of efforts to really systematize things in that area. Before that, I think the internet was so much the Wild West of the universe that no one really thought about, what does it do for people, businesses, professionals, that there is all this information out there about them online. After that, my next step was a startup called Delve, where we applied artificial intelligence to user interface problems in the mobile space. Again, there was this big disruption wave where people started using smartphones to do everything. And increasingly it became obvious that it wasn't really tractable the way people were using them. There's too much information flooding onto people's smartphones. There were a lot of user interface problems in that area. And this domain of artificial intelligence, of using learning techniques to winnow down to the most important pieces of information, seemed like an opportunity to add a lot of value to a real problem people were having. Finally, I transitioned from that startup into the big tech world of Alexa AI, where there was this amazing opportunity to innovate in conversation and dialogue systems after the kind of big step into this space that Amazon made by launching the product Alexa. So on to Alexa. This was sort of the biggest challenge I think I'd ever tackled in my career. There's this huge unresolved research problem. How do we describe, model, and understand the way humans communicate both with each other and now with machines, with smart speaker devices like the Echo and Alexa products? There's also this huge amount of data involved in the Alexa space, speech data and interaction data, the opportunity to have a massive impact with a really exciting and rapidly growing product. So I'm just going to jump into some specifics of the kinds of problems that I work on at Amazon. And at the end, I kind of will loop back and talk a little bit more about some of my specific learnings from my own career path that I think are beneficial to anyone across the board, certainly anyone coming from a tech background, studying engineering, sciences, etc. But first, the dive into conversational AI, which I think is an incredibly interesting space. So the way we think about this space, conversational AI, is really, we start by thinking, why is it that machines can't learn to communicate like us? Or can they? And when we look at the timeline of how people have been interacting with computers, going back to the 1950s, it was all about typing. And the first big disruption in that happened in 2007 with, well, several product launches, the iPhone and Android, actually, around that same point in time, where the touchscreen became reality. And we started to think about smartphones and tablets as things that you could interact with more tactily. And that's obviously made a huge change in how people think about and relate to computers and devices in general. And it was 2015 really where this concept of talking to the computer through Alexa's launch really became reality. And that's been just a tremendous force for change. You can see that, the entire space of smart speaker devices has been created through this massive disruption of the Alexa product launch. So I just wanted to show you the brief picture of what is Alexa in this day and age. You've probably heard of Alexa. You've probably seen an Alexa or Echo device or other Alexa device. This is a snapshot of a couple of the devices that Amazon makes directly that are Alexa devices. There are also many third-party devices made by our partner organizations that have Alexa embedded within them. But you can see here, Alexa is, sure, there are these smart speaker devices, but Alexa is much more than that now. Alexa is also screened or multimodal or touch capable devices as well that also support visual interaction in addition to that primary modality of speech. So how do these devices work? This is gives you some little cutaways here of what an Echo device actually looks like on the inside. And probably our most popular device, the Echo Dot, it just kind of gives you a picture of what are the main parts of that. You can see that round disc-shaped dot actually has a whole bunch of different microphones embedded within it. Those little ripply dots on the picture on the left are actually the microphones embedded within an Echo Dot that enable it to do what we call far-field voice recognition. That means that they can identify a speaker's voice, hone in on that speaker's voice, using the tiny discrepancies in sound between those 7 different microphones, and filter out a whole lot of noise from the actual signal, and use that signal to establish a remarkably clear picture of something that's been said all the way across the room from a significant distance away when someone isn't even looking in the direction of the Echo device. So what do people do with Alexa? So this just gives you a little picture of some of the kinds of skills that we support that are developed by other companies, other developers, third parties that run on our Alexa devices now. You can ask Uber to get you a ride. You can tell your thermostat to set the downstairs temperature. You can ask Pandora to play the latest songs and hits. You can ask for account summary information from banks. You can check in on your Fitbit status, and you can control other smart home devices like door locks. And just to give you a picture of what kinds of things people actually do on an everyday basis with Alexa, it's pretty amazing. People do a ton of different things. They play songs, set timers, control their smart lights, streaming music. Obviously, this is a big use case. Reading news, getting latest news updates, adding items to shopping lists. And over 80% of the households surveyed that have Alexa have 2 or more people conversing with their Alexa devices. And they have these devices in lots of different rooms and houses, kitchens, living rooms. These are all popular places for Echo devices. So this is just the little snapshot types of devices now that actually have Alexa in them. They're all over the place. We are in tons of different products at this point. So I'm going to talk now a little bit more about the specific area that I work in and that my team works on, which is this space we call conversational AI. And that means really understanding the parts of language. Now, you might think language doesn't seem so hard. I mean, there's a picture of a 2-year-old, right? A 2-year-old can understand a pretty good amount of language. Their parents can talk to them, maybe not about really sophisticated things, but they get it, and they learn language. It seems like it comes very naturally and easily to little kids, right? But there's a lot of parts to this problem. The first part of the problem is what we call automatic speech recognition, the what did you say part. If you think about it, This is essentially transforming a signal, an audio signal, into a stream of text. And that may be not so hard if it's recorded in a studio in a really clean environment. But imagine, if you will, and we call this the cocktail party problem, that there are a whole bunch of people standing around in a room all talking to each other, and one person blurts out Alexa and asks for Alexa to do something. That's actually quite challenging. Sorry about that. So that we call that the cocktail party problem. So that's the first part of our language understanding chain here. The next part is understanding what you mean. We call this natural language understanding. Alexa, is it hot outside, for example? The answer no doesn't really convey the right kind of response that we're looking for. When we say, Alexa, is it hot outside, we don't really mean literally, is it hot outside? We mean, what's the temperature outside, right? Or what's the weather like outside? So we want something that's more useful as a response. It's 72 degrees in Sunnyvale, for example. That's not what we actually asked literally, but that's what we really mean when we say that. So understanding that meaning is tricky. The next step of our language understanding problem is what we call inference. So when we say something like, who was the president of the United States when Barack Obama was a teenager? This is hard because the answer isn't obvious. Even to a human, it wouldn't be obvious. In fact, even if you handed a human an encyclopedia, it might take them some digging to figure out the answer to that. In this particular case, there are actually 3 presidents who were president of the United States when Barack Obama was a teenager: Jimmy Carter, Ronald Reagan, Richard Nixon, and Gerald Ford. Then there's this other problem we call context modeling. So this is all about understanding what 2 people in a conversation both know. So, for example, who is Barack Obama? Alexa could respond, Barack Obama is the 40-something president of the United States. Then a user could say, who is his wife? We call this a NAFRA resolution. This is a tricky problem, honestly, because you have to understand his now refers back to somebody that we were just talking about in this conversation. But then imagine a next interaction where a user says something like, when was she born? Now we're not referring back to Barack Obama, we're referring back to Michelle Obama, Barack Obama's wife. The she actually refers to a different person in the conversation. So that's super tricky, understanding who that refers to. And that's part of this context modeling problem. So personalization, this is another part of what we both know. Answers that aren't always not only not literally what we're asking, but maybe more interesting or more engaging or more correct to a particular individual. So if you ask Alexa, what's 42? Well, to me, the answer 42 is the answer to life, the universe, and everything. The trick is knowing what the question is a really cool answer. And that refers to Douglas Adams and some of his writings. But to somebody else, that answer might be completely meaningless. So that kind of personalization is really important to making Alexa feel smart to our customers. So this big problem of how do you respond in a conversation? Alexa, what movie should I watch? Well, I don't know. There isn't necessarily one right answer. That's a really hard dialogue modeling problem. And finally, this problem of natural language generation. How do we take an actual response that we've generated through our dialogue modeling process and turn it back into something that is speech and is intelligible to our users? So I live in Chicago. This station broadcasts live from Chicago. Think about that. Those sorts of pronunciation problems have to be captured there as well. So just a quick picture that kind of walks through how this actually works in practice. When you say something like, Alexa, is it hot outside? That audio gets captured through a signal processing pipeline that runs on our device. and turned into what we call a beamformed signal. Beamformed means we know where that signal came from. The wake word detection engine, that's the thing that sits there and listens for a person saying the word Alexa, which is one of our wake words available on devices. Once that wake word is heard by the device, it opens up a stream to the cloud. And the cloud is where we run our automatic speech recognition systems. That converts that audio stream, the waveform for Alexa, is it hot outside, into a stream of text. That text goes into our natural language understanding, or NLU engine, which classifies it and says, what they actually mean is a get weather intent. So then, of course, there's what we might call contextual understanding or artificial intelligence, which would layer on top of that, looking for contextual clues like what is the person's location, Sunnyvale, Atlanta, Georgia, etc. And then that has to get passed into a response generation pipeline. And ultimately, a text-to-speech pass goes through and says the weather in Atlanta is rainy in this case. So just one of our common themes around this, data-driven machine learning. Every one of the parts of that pipeline is built around machine learning. That means that it's statistical in nature, it's probabilistic in nature. We build these processes that are more robust to noise and ambiguity than any sort of rule-driven or deterministic algorithmic approach would possibly be. It's also portable to new domains and languages, which is incredibly important as we're now expanding Alexa all over the globe. This just gives you sort of a picture of how our training pipelines work. Training these systems is incredibly important. Every day we're gathering more data, and Alexa is becoming smarter as we train her to update our models. So just a little bit about how the signal processing works. I think it's always a thing that people are curious about. I don't know if you can actually hear this very well. It may not come through well in the... So if you can't hear that very well, my apologies. That's actually showing you what a noisy background audio capture from an Echo device would sound like. And it is quite noisy. And we do something called acoustic echo cancellation, where we actually take that audio playback, take the echoes, take the noise, take the music playback out of it. And what we end up with is a cleaned audio signal. That cleaned audio signal is much easier to actually do speech recognition on top of. And this is just a picture of what our deep neural network powered speech recognition systems look like. There are two parts of those systems. There's what we call acoustic modeling, what we call language modeling. Acoustic modeling translates the actual raw audio waveform into a set of phonemes, which are the actual sounds in a textual representation or in an intermediate representation. And then what we call a language model. That language model takes those phonemes and comes up with what the actual words are based on a statistical model of the most likely words in conversation or interaction. Speech synthesis is another really interesting part of this problem. So, what our systems and third-party developer skills actually output is text, right? They say, the response to this question from a user should be something like, she has $20 in her pocket. But that text can't be rendered in that form. It has to be normalized. It has to be converted into what we call phonemes again. And then we actually have to generate the audio waveform.
She has $20 in her pocket.
And then Alexa actually reads it out in her voice. We use deep learning across all of these parts of this system, both our wake word engine, which actually runs on our devices, as well as the ASR, NLU, and TTS systems. All of these require a ton of data. We have tons of data, and we use them to train deep neural network models. This is just a little snapshot of what the sort of organizational picture of Alexa looks like. All of our external facing projects are here. The Alexa Skills Kit, which is a way that any developer can go and build skills for Alexa, as well as the Alexa Voice Services System, which is a way to actually integrate Alexa into other hardware products. Can be anything from a fridge to a toaster oven. And finally, these touch points with academia and entrepreneurs, and that's where my work comes in. The Alexa Prize is part of that. So I'm just going to jump in a little bit to this interesting and incredibly challenging competition called the Alexa Prize that we've been running. And this is one of the projects owned within my group and my team right now. It also is, it's a very interesting thing because it is both a challenge, a competition that universities are competing in. At the same time, it's also a collaboration. It's not something that universities are doing by themselves. It's something they're doing side by side with Amazon. So it's a set of top research universities that are competing to build conversational experiences that are actually delivered on the Alexa platform. So people can talk to these conversational bots or social bots directly from their Alexa device just by saying, "Alexa, let's chat." This lets us deliver an immense amount of data at scale to these social bots. And it's enabled really amazing work by the universities who are competing. This is the list of universities that competed actually last year. Last year's competition was won by the University of Washington, the sounding board team. And the runners-up were Czech Tech University and Heriot-Watt University. So this is a global competition. Just wanted to touch on what this competition is really about. This is about social interaction, being able to chat with a bot in a conversational setting, but about real-world knowledge. So the kinds of conversations that you might have while standing by the water cooler at work, perhaps. That's what we're trying to enable Alexa to do. This problem is so hard and has so many parts of it that we know we can't solve all of them ourselves. This goes well beyond where Alexa's current capabilities are, where any sort of conversational agent or digital assistance capabilities are. So that's why we wanted to do this as a collaboration with some of the world's greatest researchers in AI. So this challenge has a couple different parts. The first part is what we call conversational ASR. That means not just understanding very specific commands to Alexa, like play music by Sting, but rather understanding, converting free-form, much more natural speech into text. Then there's this conversational NLU problem. How do you understand the kinds of free-form, free-flowing, natural utterances that people might say in a regular conversation? This is not like just the intense, like get weather that we were looking at before. It doesn't fit well into that approach. Then there's these problems like dialogue planning and context modeling, understanding what the best strategies are, ranking and selecting responses, generating those responses. Personalization still shows up here, of course. And then other problems like knowledge ingestion and reasoning. So how do you take things like, for example, the latest news and updated articles and incorporate the information, the concepts and the topics from them into a conversation? That's really hard. And finally, there's this problem of dialogue evaluation. How do you tell if something is a good conversation or a bad conversation? How do you tell if somebody is likely to react well to it or not? There's no standardized metrics in research literature, frankly, that actually perform very well on this problem. So it's hard. This just shows a little bit of what we have accomplished in our first, now about a year and a half of the Alexa Prize competition. Over a 40% reduction in word error rates in our conversational ASR system. This is a new system. It's trained differently on totally different data than our general Alexa ASR systems. We've done a lot to collaboratively with universities to solve this problem of dialogue management. How do we satisfy users' goals through sequences of interactions? How do we keep users engaged while minimizing frustration? How do we handle ambiguity, keep it robust to errors and speech recognition, and so on? Finally, we want it to be coherent. We want it to be engaging. So the responses that bots deliver should meet all of these many goals. So how do teams actually tackle this problem? I mean, they're some really great scientists, but this is a super large problem. It's not just like train a model or come up with an algorithm to solve one limited use case or one sort of toy scale thing. This is really tricky stuff. Be able to build a bot that can talk about a wide variety of different topics convincingly, compellingly with our customers. One of the things that we've noted is that all the top teams have used some kind of what we call multi-bot or ensemble strategies, where they found that one model or one bot or one approach didn't work well across the board. They needed to tune a whole variety of different models, and they had to focus those models on different areas, such as breaking them down by topic. For example, things like sports, politics, fashion. Each one of those have different data sources that they might draw from, and likely different models that actually describe the way the dialogue flows in those areas. They also broke down by data source type. So some of the teams are using sources like Reddit, a very popular kind of internet chat site, Twitter conversations, as well as the Washington Post newspaper articles. Finally, they broke them down by different intent areas, so different types of conversation, like chit chat, opinion, knowledge. We've seen them have a lot of success with that strategy too. It turned out there are some really hard sub-problems within this area. One is, how do you track dialogue state and context? How do you track user sentiment and user feedback? They've also looked at different ways to measure engagement and customer experience, different strategies for driving forward conversations and leading to longer dialogues and better ratings from customers. Finally, we've discovered that I think, like a lot of problems that have content sourced from the open internet, you deal with issues of profanity and offensive speech that become really challenging. So how do you filter out things that just are not appropriate for kind of general purpose conversation? How do you detect some of those? They're not always easy to detect. This is a problem that lots of big tech companies have been dealing with. Finally, we've worked with the university teams to figure out, how do you learn from feedback? How do you ingest user feedback into your learning processes? So we give them a lot of information on a daily basis about a whole bunch of different metrics that we've developed around the quality of conversations that people are having with their social bots. So we look at, we call response error rates, where we measure and estimate whether or not a turn is an accurate response or a valid response. We look at how coherent these conversations are that people are having with their bots. We look at how engaging these conversations are that people are having with their bots. And then we work with them qualitatively to identify what are some of the gaps, and can we understand from the sort of more free-form feedback that customers provide what some of these experiential gaps are. And these have all led to better customer experience, higher ratings. This is a little snapshot of what happened over the course of the first year of the competition, from May of 2017 through January 2018, with originally 15 social bots and then the finalist teams, and how they progressed over the course of the year, which is really impressive, I think. Just shows the amount of improvement that we saw in a very short period of time. We've always known that this was a big problem and that this was not something that would be solved in 1 year. Our goal here, our big goal, the grand challenge goal for the Alexa Prize, is to build a bot that can have a coherent, engaging, interesting conversation for 20 minutes. And we have some specific ways we're measuring that. But 20 minutes is a super hard objective. I mean, there are a lot of people I couldn't have a 20-minute conversation with. I don't know if a lot of people could have a 20-minute conversation with me. So imagine being able to build a bot that can actually engage in that level of real compelling conversation for 20 minutes. It's a big challenge. In 2017 and still, the Alexa Prize is one of the top 10 skills by usage for Alexa users. We've collected hundreds of thousands of hours of conversational data. It's now at this point significantly higher even. That was in the first year. And we've made unrelenting progress in terms of the quality of the bots. It's been incredibly impressive to see how the universities have worked hand in hand with Amazon and with the tools that we've given them to drive success in this area. This has also turned out to be an amazing source of research output. We have both been able to produce a ton of papers ourselves out of our Alexa Prize team inside Amazon. We have also seen a ton of publications that came out during the year last year, as well as an increasing number that have come out over the course of the year this year from competitors in last year's competition and competitors in this year's competition. And this has been fantastic. We've really driven the entire field of research in this area of dialogue and conversation in a new direction through exposing massive amounts of real customer data to a bunch of universities that otherwise never would have been able to get access to this level of data. So now that I've filled your eyes, minds, ears with a whole bunch of hopefully interesting content about Amazon, about Alexa, and about the Alexa Prize competition, I just wanted to talk a little bit about some of my own life lessons, some of the things that I've gotten out of sort of frameworks, heuristics for thinking about my own career and kind of guiding and steering decision making for myself that I think are useful. And I've connected them up a little bit to some of these Amazon leadership principles. If you've never heard of these leadership principles, this is something it's come from Jeff Bezos directly. It's a framework that we have for thinking about leadership at Amazon. But I think it's actually incredibly applicable to life outside of Amazon too. Pretty much I think to your career almost anywhere. You have to pick and choose which of these 14 leadership principles might be the right ones for you to focus on at any given point in time. But it's a really powerful framework for thinking about how do I make decisions? How do I operate professionally in my career, in my academic life? I highly recommend just searching for this on Google, look for leadership principles, read what they are. It's a 5-minute read. You can spin through. There's a whole website devoted to them on Amazon, on Amazon's actually careers page, I think. And it's worth reading and thinking about and seeing if you can figure out some ways to apply this to your own life. Anyway, back to me. One of my big learnings has been that opportunities come out of picking problems that are good. And by good, I mean well matched to the things that you do well and that you feel excited about and energized by. For me, I think it's focusing on cultivating my own strengths and finding those areas where my strengths add the most value has been incredibly important. I never studied artificial intelligence. I studied computer science in general back in college many years ago. I studied physics extensively. I learned a lot about how to learn, but I'm not practicing physics to this day. I've never actually been a physicist. I think what I got out of my college education, certainly as an undergrad, was learning about how to think about problems, learning about how to learning about how to tackle complicated learning problems myself. And that's been incredibly useful for me. And one of those strength areas that I found for myself has been really being able to digest leading edge research and coming up with ways to apply it to real problems in industry. Early on in your career, you might not know what your strength areas are, and that's totally okay. I certainly didn't, and that's totally normal. It's something that you do learn over time, though, and it's important to always put time into thinking about what's going well and what's not going well in your own career. What do you like about where you are, and what do you think you could do better? So a few concepts that have helped me along the way, I just wanted to touch on quickly. This is back to these sort of heuristics for decision making, heuristics for improving yourself. So the first of these is what I called continuous learning. There's a leadership principle at Amazon actually that lines right up with this. It's called learn and be curious. But when I think about it, I think about continuous learning. What that means to me is don't get too comfortable too quickly in a single domain. Depth of knowledge is important, but you don't want to be overly specialized, especially not early on in your career. Breadth is important. You're never too old, never too young to keep learning. If you're always learning and you're always diving into new topics, reading, expanding your areas of expertise, you're going to succeed in life. I'm 100% certain of that. Your education, your degrees, these are enablers. They're really important enablers, but there shouldn't be limiters for you. Those should frame the way you think about problems. They should inform the way you approach your career, but those are not the constraints for what you can do in the next 30 or 40 or 50 years of your life after college. So the next kind of heuristic or concept here is tackle big ideas. This is one where I feel like a lot of people could use a lot of work. I see this especially with some of the younger people actually who work for me on my teams. We have a phrase for this, think big. This is another one of those 14 leadership principles in Amazon. But if you don't think about big problems, big ideas, if you let yourself get stuck in this thinking small modality, you'll never get to big results, right? I mean, if you think big and you tackle big problems, you will probably fail sometimes. You may even fail a lot of the time, but you'll learn a lot in the process. If you let fear always steer you away from those kinds of big problems and big thinking, if you tell yourself, well, I'm not good enough at this to do something that big, or this job is too challenging, or I shouldn't apply to this, or I shouldn't go out and start a company myself. If you let yourself think that way, you'll never get to the big results. Always be willing to fail fast. Failing fast is great. That's one of these Silicon Valley mantras. And I think it is one of the better things that's come out of Silicon Valley culture, honestly, in the last few decades. The idea that it's not just okay to mess up and fail, but that it's good to mess up and fail sometimes because we learn in that process. If you don't mess up and fail, you'll always wonder if you've missed out on something. I think that's really important. Another one of these, I think really useful leadership principles is this concept we call at Amazon, are right a lot. Of course, everyone wants to be right a lot. That sounds kind of like an obvious self-fulfilling prophecy. Of course, I must be right a lot. But what it really means is it's not about just being right. It's about how you get to being right. And getting to being right is all about how you build heuristics for decision-making. None of us are born with the ability to always make good decisions. In fact, when we're younger, we generally make less good decisions just because we have less life experience and failures to draw upon. So I think the way I think about this concept of building your own heuristics and being right a lot is that you should always challenge your own thinking and work to disconfirm your beliefs. So treat your beliefs as you would a hypothesis in the scientific method, right? You want to disprove, disconfirm, find holes in your own logic or thinking. This will over time improve your judgment, improve your instincts. You'll throw out bad assumptions and learn to make good decisions faster. I think this is maybe the last one here of my slides, but I think it's a really important one. Certainly, if you're in industry anywhere, in the tech world, frankly, anywhere even outside of the tech world, put the customer first. I feel like this oftentimes gets dropped sometimes in Silicon Valley. We hype things, we get obsessed with technology for its own sake. That's technology is great. I love technology. I love artificial intelligence, but these are tools that we use to solve real problems for real people. So at Amazon, we call this customer obsession. Customer obsession is one of those leadership principles. Again, this is all about the idea that we should start with a real customer problem or a real way we can create value for customers, and then work backwards from that. And what that means is don't start with a piece of technology. Don't start with a project that you just think would be cool. Start with what the real impact you want to have is, and then figure out what are the pieces of technology you need. What are the kinds of algorithms you need to create? What can you use to achieve that outcome? So if you forget this one, all of that innovative, deep thinking, disruptive ideas, great execution, everything else won't help you. Create value and joy for your customers, and products will succeed in the marketplace. That's really all I can say about that. Finally, don't make assumptions. Test them, validate, ask, treat the process of building technology, building products, working in the tech industry as a scientific mission where you're trying to figure out what the right answer is, the right way to really create value for customers. And that's what I've got for you tonight. That is the end. Thanks. I'm ending my screen share, I hope. Let's see if that works. There we go.
There we go. This is very interesting. Very topics. And if there was anything else you needed to add about the future or where you think we're headed with technology, particularly in conversational AI, it's all around us. Where do you think we're going to go in the next 3 to 5 years?
Absolutely. Yeah. I think that people are going to be interacting more naturally with devices. I think that if you look at, there was actually a very interesting interview with my boss, Rohit Prasad, who's our VP and head scientist at Alexa, that he gave just the other day about how ultimately our long run vision is to kill off this idea, if you will, of standalone skills for Alexa. This isn't happening right now, but it's happening in the long run, I think, where we're going to connect up lots of knowledge and capabilities to systems like Alexa, but that asking for those knowledge and capabilities won't require remembering specific phrases or words. It will just be a much more natural exploratory process. So I think that's part of what's going on with conversational AI. Broadly speaking, we're seeing a ton of devices now where it's not just you can speak to them. It's mixing different modalities together. You can touch them. You can use touch screens on them. You can see lists of information presented very efficiently to you on a screen. But then you can give guidance, direct, and ask for information with voice. So I think that those are some of the key innovations that we're going to see coming up in the next few years.
Yeah, I think it sounds almost like the whole field of human-machine interactions is changing as we speak. And that itself is going to create a whole slew of new jobs and workforce skills. So
Absolutely.
Yeah, it was really good to see all those Amazonian principles of leadership, because leadership is leadership, whether it comes to this company or that. very, very good that we could hear it from you.
And that's actually one of a very interesting concept that we have at Amazon, is that leadership is not just something that, you know, the boss does. Leadership is something that comes at every level of the company, from fresh new grad hires all the way up the chain. So we interpret that word leadership in a pretty broad sense. And I think, you know, the best kind of leadership is the kind that comes from the ground up, and you know, where the bosses, managers, directors, VPs are supporting the leadership efforts of people on their teams, rather than handing down directives to them.
Sounds amazing. And I do appreciate it, all the time that you spent in preparing the slides and talking to us, Raefer. And
Absolutely.
once again, on behalf of everybody that's listening in, thank you so much, and really appreciate having you lead off on this series of Future of Technology. And thanks again.
Thank you very much, Preetha.
Most welcome. Bye-bye, everybody. And join us again on the 28th for our next talk. Thanks. Bye-bye.